Well, good afternoon, everybody. I'm Alessandro Arcidiacono from Italian company Enginsoft. I'm very glad to be here to present the successful work done by me and my colleagues on the cloud-based design of hydraulic turbine. Well, I will focus on the real initial problem and the solution proposed, then on how the Fortissimo project within the I4MS framework helped us achieving our goals, and finally, the impact on the major stakeholders. Well, the first question to be answered is who. In our case, the SME is related to the hydropower sector. A renewable energy whose exploitation is more and more growing all around the world. The goals are to first increase the renewable energy exploitation globally, and to do that, increase the European SME market share outside the national borders in Europe, in America, also in the emerging countries. The reference products are small hydro turbines of Kaplan type, which means that the net power produced is less than 10 megawatts. In the top figure, you can see the three most common types of turbines, the Kaplan in the big picture, and Francis and Pelton turbines. The solution proposed is an innovative Kaplan turbine layout with axial vertical feed, water feed, instead of the classical radial layout. This solution is much cheaper than in terms of civil infrastructures than the original one, and it increases a lot the turbine versatility. And also, if well designed and optimized, the efficiency is very close to the standard turbine layout. How can such a turbine be designed? Well, through high-fidelity computational fluid dynamics. Within this project, a CFD virtual customization tool was created that enables the SME to design, optimize, and customize its product, the turbine, based only on depending only on the user input data. All the technical passages from geometry update to mesh generation to CFD simulations are carried out automatically by the CFD virtual tool. The advantages of this tool, well, for sure, the accuracy of the CFD model, because it takes into account all the main physical aspects, such as, for example, the cavitation. The possibility to parameterize many of the geometry and the operating conditions data, enabling the SMEs to do optimization and customization of its product. Well, the virtual simulation is obviously much more faster and cheaper than physical experiments. The problem is that high-fidelity computational fluid dynamics analysis are really computationally expensive. For this reason, the HPC is fundamental to reach a good solution in a relatively short time. Also, the CFD technical know-how is very important, as the solution reliability depends on it. So, how did I4MS help us? Well, Fortissimo project was the ideal framework to develop such a virtual tool, because it provides the HPC technology access with no direct hardware costs for the SME. As a matter of fact, the code license and the HPC license is provided in a pay-per-use mode through a totally cloud-based access. Also, the CPU availability is very large. The SME originally had 8 workstation with 8 processors. Then, with Fortissimo, we passed to 128 processors. In other words, Fortissimo is a total and efficient was a total and efficient outsource for the SME. In our case, the SME in the hydropower sector is the Italian turbine manufacturer ZECO, while the HPC provider is the Italian supercomputing center Cineca, and the CFD experts is Enginsoft. Thanks to the collaboration among these partners, ZECO managed to overcome the HPC technology's barrier to entry. Without the Fortissimo help, ZECO would not be competitive on global markets, mainly because of slower development time due to physical testing, lower product efficiency due to the lack of optimization, and the product customization would be much more difficult. Regarding the impacts of the projects, well, on the CFD expert Enginsoft, for sure we gain a very important expertise in a new and promising technology that is cloud computing. And also the virtual tool we created is also adaptable to other similar customers in the turbomachinery sector. For this reason, we expect a 10% growth in turbomachinery business, which means 2 additional customers per year of this type, with a profit of 50,000 euros per year per customer. Regarding the HPC provider Cineca, there's the expectation to expand the HPC business to at least 2 additional customers of this type per year, with a revenue potential of 100,000 euros. There's also a benefits for the entire community, because every single plant of this type that is sold means a 10 tons of carbon dioxide reduction of emission in the environment. Well, finally, the benefits on the turbine manufacturer, ZECO. Well, first, thanks to HPC and thanks to Fortissimo, ZECO had a 75% reduction on simulation time, which leads to a 50% reduction in delivery time of its product. A 24% reduction on investment cost of the entire plant over 2 years, mainly thanks to lower civil infrastructure costs due to the innovative axial layout, lower maintenance costs due to cavitation prevention thanks to the CFD code, and higher energy production because of lower maintenance stops. Starting from a project cost of 300,000 euros, there's the expectation for ZECO to sell 2 additional plants of this type per year, with an income of 1.5 million per year per plant. In conclusion, thanks to this Fortissimo project, ZECO managed to gain a competitive edge on both local and global markets, thanks to the development of an efficient turbine design based on high-performance computing. Thank you very much.